What's up, guys? My name's Alex, and welcome to the Archer's Paradox.
10!
In March of 2020, the US government issued a quarantine, and all archery ranges closed. At least for me, this was pretty terrible. Shooting distance was completely out of question, and for most people, the only forms of practice they had were blank bailing and SPT.
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't.
But what if I told you it was possible to simulate outdoor distances with just a blank bail? Mind-blowing, right? Well, the answer is really simple. Just shoot your arrows higher on the blank bail. But how do you know how high you have to aim? That's where the physics comes in. In this video, I'm going to show you how to calculate how high up to put your target to simulate any distance. If you're impatient and don't care about cool physics, you can feel free to skip to the equation at the very end using the timestamp in the description. It won't offend me, I won't know.
Or will I?
So right off the bat, we're going to make a few assumptions in this experiment. The first one is that we're going to pretend that you're in a vacuum, and that means that there's absolutely no air whatsoever. This will allow us to disregard air resistance during our calculations. And besides, you're probably like 2 meters away from your blank bail target anyway, so air resistance would have a negligible effect on your arrow's flight either way. The second one we're going to make is that your shoulder height, which is the distance between here and the ground, is going to be exactly the same as the height of the center of the target. The third assumption we're going to make is that your bow is 44.5 pounds. The fourth one is that a target is perfectly perpendicular to the ground. And the fifth one is that you have an impeccable release. Some of these assumptions, particularly the ones concerning the shoulder height and poundage, can cause a lot of variation. I will be minimizing a lot of these assumptions in a future video, so be sure to stay tuned. Alright, so let's get right into it. This whole experiment revolves around one equation, the range equation. The range equation is as follows: delta x equals v naught squared times sine 2 theta over g. Now, you might be wondering, what the heck does all that mean? So let me break it down for you. Delta x stands for change in x. This is going to be the distance we plan to simulate. For the example's sake, we're going to go with 70 meters. V naught is the initial velocity of the projectile. In this case, it'll be the velocity for the arrow as soon as it leaves the bow. So how do we figure this out? So I contacted my buddy Anthony over at Short Shot Archery and asked him to run some tests for me. You guys should all check out his channel, which is linked in the description. Seriously, check him out. He makes some pretty awesome videos. So Anthony has a shooting machine, which means that he can make his bow shoot the exact same shot over and over and over again. And these shots are perfect. As you can see, this machine has a trigger that makes sure the release is impeccable, hence why this is an assumption that we need to make. Here, Anthony uses his machine to shoot an arrow through a device called a chronograph. This chronograph will give us the speed of the arrow in feet per second. I had him run this test 5 times in a row using his 44.5 pound Hoyt bow to minimize experimental uncertainty. These are the results. So it's pretty clear that the average arrow speed leaving the bow is 201 feet per second. Since we're working in meters, let's convert that into 61.2648 meters per second. So let's move on to g. G is a constant for the acceleration due to gravity. As long as we're on planet Earth, this is always going to be 9.81 meters per second squared. So what about theta? We kind of skipped over it there. Theta represents the angle that your arm is at relative to the right angle. So how do we get theta alone? Well, when you isolate the sine 2 theta term, you get sine 2 theta equals delta x times g over v naught squared. But how do we get our 2 theta alone? We use inverse trig. Therefore, 2 theta equals the arc sine of delta x times g over v naught squared. Divide this by 2, and there you have your theta. In this example, our theta is 5.271 degrees. This is the angle you need to shoot at. But how do we translate an angle into how high up on the target we need to shoot at? More trig, my friends, more trig. You're going to need to do just one more measurement, and this is how far away from your target you plan to shoot. In this case, let's assume that our archer is standing 3 meters away from his target, from his blank bail target. So this means we can have the following right triangle. But how do we get the height of it? So there's a saying called SOHCAHTOA, which means that the sine of an angle is equal to the opposite side over the hypotenuse. The cosine of an angle is the adjacent side over the hypotenuse, and the tangent is the opposite side over the adjacent side. Here we know the adjacent side length, which is the distance we are from the blank bale, and the angle. We are looking for the opposite side, therefore we want to use tangent here. We can set up this equation. Tangent of 5.271 degrees is equal to the opposite side over the adjacent side. Therefore, if we want to solve for the opposite side, you get the adjacent side times the tangent of 5.271 degrees, which equals the sides of the opposite side. This value is going to be how much higher than the center your arrow should be landing to simulate any distance. If you want just a quick equation to plug everything into, here it is. The distance from the target times the tangent of 1/2 the arc sine of the distance you want to simulate times g over the initial velocity of your arrow squared. Alright, so if we plug our equation into the calculator, 3 times the tangent of 5.271 degrees turns out to be approximately 0.277 meters, which translates to 27.7 centimeters. So what we're going to do is we're going to take the center of the target. It's okay if you eyeball it, it doesn't have to be perfect. I'll actually be posting a video in the future about how to actually find the dead center of your target bale. So you're going to guess the center, well mine is already marked, and we're just going to measure 27.7 centimeters up, and we're literally just going to draw a line. Alright, and at the top of the line up here, that's where our 10 ring is going to go. So now let's grab our target, line it up with the 10 there, line the 10 up with that dot, and boom, you just simulated 70 meters. Thank you so much for watching this video. If this helped you out, please drop a like, and for more cool archery physics material, please consider subscribing or visiting my website at www.thearchersparadox.com.